How's your Windows experience been so far, Dom?
Pretty good. I mean, I mostly play games on my PlayStation, so my Windows experience has been mostly streaming. Uh,
Yeah.
it's strangely pleasant. It works.
Yeah.
I'm kind of shocked how well it works, actually.
So you haven't been playing video games on your fancy gaming PC. I thought that was the kind of point of it.
No, I bought this for streaming.
Amazing.
There's only 3 graphics cards that have the stream encoder, and I think we each have one of them now.
And I wish there was a way that like OBS could assure me that it's actually using that, because I felt like we invested quite a bit of money into that exact feature. And I think there's an option, I think, in the settings that says it's using like the NVIDIA encoding thing, but I don't actually know if it's actually using it, like.
Yeah, I turned on the stats, and you can see how fast it's encoding frames.
Okay.
There's like a stats panel.
Okay.
Which is nice.
I think I've futzed with OBS enough for today, so I think I'll check that out next time.
Fair.
Yeah.
Fair. No, I just started playing Ghosts of Tsushima.
Yeah.
Which is amazing.
Is it?
It's actually amazing.
Yeah.
It's what Assassin's Creed really should have been for a while.
Yeah. I've heard that it's like the best Assassin's Creed game, but also has I've heard that it feels slightly dated. That's the criticism of that game. Is that the open world conventions seem a little bit cut and dry.
I could see that, but the story stuff it's like really meaty stories though, and like kind of so open world stuff, and like I don't like the open world stuff anyway.
Yeah, I'm not sure what they're comparing to. Like, are they comparing to God of War or like Horizon Zero Dawn? Like I'm not. Maybe I should actually just like read what the actual criticism is, because I think people have just claimed that it just seems a little bit.
Yeah, and I'm early in it. Maybe it gets really boring, but like, man, it's so pretty and fun just to wander around, and the mechanics they picked are extremely solid. So,
and
would recommend.
Combat is it like Soulsy, or is it a little bit easier than that?
I think it's easier, but it's got kind of that edge to it where there's like a timing component to it that you do end up in a Soulsy space.
I've heard it, like, is it like Arkham where like there's like a little button thing that tells you when you can parry or you can counter or anything? Okay.
No, it's like if Arkham had no button prompts, and it kind of works exactly like that.
Okay.
Yeah.
Yeah.
It's great though. You feel so badass.
That's awesome. I don't think I ever got good enough timing wise for a lot of like the Souls and Souls inspired games. Like I could never parry in Bloodborne. It was just like I could not get the rhythm down at all.
No, it's impossible.
Which is funny because I think in order to actually get good at that game, you need to be able to parry, right? I guess
I think so.
It's beatable without parrying, right?
It's hard.
Yeah. And
you have to get lucky a couple times, and then you can beat it, I think.
The problem with parrying in Bloodborne is that if you miss, you're screwed.
You're screwed. Yeah. You're totally screwed.
Yeah. Anyways, so for the game, we're not adding a parry to the tank game. Not yet, at least.
Not yet.
But so we did add last time, getting used to the lag here, we did add this.
Whew, so good.
Right? Oh man, this is like borderline unplayable on my because I'm playing through
that's funny.
The capture card.
Oops, sorry.
Oh, it's okay. Oh, we have a bug. Our keyboard doesn't really understand when we lose focus.
Ah, bummer. What does it say? That looks awesome over here.
It looks pretty good. Yeah.
Yeah.
Yeah, it's just a slight amount of latency. I guess this is what it would feel like if we were playing the game.
Here's your net play.
Here's my net play, exactly. Yeah, with that amount of latency. I wonder if this can be measured. This feels like a third of a second, maybe half.
Oh, that's pretty rough, actually.
Yeah. Okay. So we added inventory last time. You have to pick up one of these blue things in order to be able to lay a turret down.
Mm-hmm.
Off stream, I started on a priority queue implementation. That's why the Pathfinder.ts is open right now, because I thought about maybe replacing the kind of like
Nice.
constant sorting that we do.
Mhm.
I don't think it's here actually. I think it's this one here. And this, when the list gets long, I think is what's, or at least one of the things that's time consuming.
It's definitely, I mean, I think this is the probably biggest performance impact in the game right now because this is huge.
Yeah. Well,
And we should use this. We should use this more. Not
we do
less,
check
so,
wall collision against every single wall in the game right now.
Mm-hmm.
We don't do any kind of space partitioning or anything like that.
That's a small check, though, right?
Wall collision.
Is it just is AABB over?
Yeah, it's an AABB over everything. Yeah. So however many walls we have, probably like a couple hundred. Yeah, it should be fast, right? But I haven't added the priority queue here.
Okay.
We could do it. It seems a little tedious to do a refactor. I mean, but if it's interesting to you, I can walk you through the implementation of the priority queue.
I'm curious what you picked. Yeah.
Yeah.
Do you write your own?
I did roll my own. Yeah, I didn't end up like
Nice.
That's actually the kind of thing that like maybe you could get like an off the shelf thing. But yeah, let me at least show you the implementation. We can see.
Hey, let me see what you got.
So the interface of a priority queue, the idea behind it is that you can push onto it just like any other data structure, an array or whatever. You can add stuff to it. And then, but when you create the priority queue, there is a notion of a comparison function. That's a comparator. And the comparator is just a classic thing that we would pass into sort, right? The sort function has this as well. You take two values of the same type, and then it'll tell you, it'll return a negative number if A should sort before B. It should return a positive number if B should sort before A, and then return 0 if they sort equally, right? So you actually initialize the priority queue with that comparator function, right?
Nice.
And then I got a little bit fancy here and basically implemented like an internal vector as the storage. So it's just an array that can grow in size as you push stuff on that exceeds it. And the heuristic that I used was just like if the length here, underscore length, I put an underscore there because there's actually a public function called length that returns this value basically. But if the length here is equal to the current storage capacity, which is just storage.length, like the array property.length, then it just copies, it like creates another array of twice the original capacity and then copies the original storage over to the new thing and then just resets it. Yeah. So that's like what most vectors do, like under the hood, right? I was actually curious as I was typing this out whether vector implementations will shrink the internal storage to reclaim memory. And it is said that I think very few data structures will do that. So be careful when you allocate, when you push 1,000 things into a vector and then remove them all.
That's good to know.
Yeah. So what a heap is under the hood, this storage. Let me create a new file here. Let's say one line, there's like one line per item. So it's just basically an array that goes downwards, you can imagine. And let's just say that the stuff that we push into the array is like just numbers. Does that work? So if you push like the number 1 in there, your array will look like this, right? And then the idea behind a priority queue is you want to make sure that implementation-wise, it is fast to retrieve the highest ranking object in that priority queue. And that's the only access you have actually to the internal contents. Most priority queues aren't going to let you like iterate over the contents or like give you a function that says is the number 10 in the priority queue. It's not optimized for that, right? The only operations that you really get besides putting stuff into it is you can pop, which basically returns the value of the highest ranking object and then also removes it from the priority queue. That's actually literally what we do in our Pathfinder, like our A-star algorithm. That's what it does, right? Pull the first thing off. And I think the equivalent of that is we update to visit, right? And then to visit, we do this shift here. line 46. So that's what the priority queue is doing. Is it's just like that's what the pop function is doing. I did implement a peek, which just lets you like look at the thing at the top without removing it. That's just some data structures give you that, but otherwise, that's the only interface you have. So it's a very simple client API for this. So where it's interesting is how we store things, right? So you basically want to make sure that like the top is, or sorry, the first item in the internal array is the thing that you're going to return next time somebody calls pop or peek, right? So the question is, what happens when you insert something into the priority queue? And let's say our comparator is like lowest numbers first. So it's like what we call a min heap or a minimum priority queue. So if we push 1, 2, 3, 4 and we pop everything out, we should get 1, 2, 3, and 4 in that order, right? Similarly, if we pushed 4, 3, 2, 1, if we popped 4 times, we should still get 1, 2, 3, 4, right? Because the queue is supposed to give you the lowest thing all the time. So let me just pick a number arbitrarily. Let's just say we push in 3. And then we push in the value 4, right? So the algorithm for pushing is that you just stick something at the end and then see if it's okay, right? Like, do we need to move anything around? And just by looking at this, this is probably fine, right? Because like we want the minimum thing in the priority queue to be at the front of the internal storage array, and it is right now, right? So when we pushed 4, it was basically greater than the maximum, so we're fine. Now, what happens if we push something in that's smaller though, right? Actually, let me make this into 6 just because it makes the example a little bit clearer. Let's say we push in like 2. Now, if we didn't do anything to reorganize this, we would get bad data, right? We should be getting 2, but we're going to get 3 because 3 is at the top. So what we actually have to do is basically like when we add an item, we stick it at the very end. And then we kind of like bubble it up. I believe that's the name of the operation. We bubble it up to where it's supposed to be.
Oh, okay. That actually makes sense because then you've got a sorted array in place.
Yeah. So the question, it's actually very similar to the thing that is already implemented, right? Because we call sort, like we basically kind of implemented this after a fashion, right? Because we basically, I'm sorry, I skipped past it. One way to bubble up is we sort, right? That's exactly what's going on here. Now, the question is can we make it faster than that, right? Because sorting here is probably doing quick sort, and it's reorganizing everything, and it's moving a lot of stuff around. Probably the number of items that it's touching in the arrays, like maybe every single item in the array, even if you're doing quick sort and it's like logarithmic or whatever.
Right, it's still, is it login or is it nlogin for quick sort?
Oh, it's nlogin. Yes, it's nlogin.
It's nlogin.
It's nlogin, and we want login.
And that's as good as we can do, with a sort of everything.
Yes. But we want login. So the priority queue internal structure uses a heap, uses a binary heap. And that's actually where the term heap in like the memory sense comes from. They call the heap in the memory sense the heap because it's a bunch of like contiguous chunks of memory that can be allocated arbitrarily during runtime. And how do you figure out what the smallest or largest chunk of free memory is? Well, you organize it in this data structure called a heap, and so therefore they just call it the heap. Didn't have to be that way, but that's how they chose that name. So the basic idea behind the heap is that you have this thing called the heap property. I believe that's what it's called. And what this basically says is that parents always, well, you basically have two things. Parents have 2 children. Parents always rank higher than their children. According to the comparator, right? Okay, so we don't have a parent-child relationship right now in an array. It's just like this series of numbers, right? But what we can actually come up with is some kind of like tree structure. And what we say is your child is at, or your children, or let's say your left child is at I times, I think it's I times 2. And I kind of screwed up these numbers a lot until I figured it out. What am I doing here? The left child is 2
plus 1
times
right child's plus 2.
Oh, right, because it's 0 indexed, right?
Yeah.
Our line numbers are a little bit deceptive here, right? But we're talking about 0 index, so this is actually plus 1 and plus 2, right? So that means that the left child of the top node, which is 3, is this second thing here, which is 6, and then the right child is this value 2. And then if we were to add a couple more here, like let's just pick 2 arbitrary things like 0 and 5, the parent of this thing is actually this one here. Because this is index 1. Sorry, the line numbers are a little bit wonky here.
Right, so yeah, 1 times 2 plus 1, 1 times 2 plus 2. Cool.
Yeah.
That's clever.
Yeah. So basically what happens is, let me restore back to this situation where we had 3 and then we pushed on 6 and everything was fine, and then we pushed on 2. And now we've violated the heap property, right? We've violated this, right? Because our comparison is like lowest numbers first. Lowest numbers are higher ranking. And the right child of this node that contains 3 is this node that contains 2. And the parent actually ranks lower than its child. So if a parent ranks lower than its child, you just swap the parent and the child. Straight up.
Nice.
Yeah. So we just do this and this. And so if you imagine when we push, you're going to basically like if this was way longer, you're going to like hop up and replace parents, like your ancestors, potentially all the way up to the very top, right? But that push operation is log of n, right? It's the log base 2 of the size of the array, right? That's the number of times that you'd actually do that swap.
That's great. Yeah, that makes a lot of sense.
Right. So the pop operation is a little bit more complicated. When we pop, what we do is we get rid of this. And then we need to figure out like what actually needs to go there at the top. So
can you assert that one of your 2 children is now the top? You can, because it has to be higher ranked than their children. Yeah, okay.
Yeah, so the way, I think there's probably a lot of different ways that you could deal with a pop, but basically the 2 is no longer in there. Actually, let me make a more well, first of all, let's say we get rid of 2, and so we have to put something at the top because it's gone now, it's invalidated. So normally what you do is you say, I'm just going to take the very last thing in the array. I don't care what it is. Whatever's in at the very end. And I'm going to just stick it in there. And then I'm going to say, like, does the heap property still satisfy in this situation? And in this case, it happens to very accidentally, right? But let me go to a situation where it's not going to. So one example is if we were in this situation after we pushed on 2, and then we push 10, right? And then we pop off of it. So we get rid of the 2, and then we get 10 in there, right? And 10 is no longer at the end. Now we're violating the heap property because 10 is the parent of both 6 and 3. And we need to restore the heap property. So popping is a little bit more complicated because you actually have to like decide which branch, either the left branch or the right branch, you want to do your swaps. Because you basically have to push, you have to like push down that 10 value so it goes into its natural position, right?
Mm.
If you just went in like binary tree order, which is usually like left then right, this would actually end up with something wrong, right? So if we just went to the left side, we would swap 6 and 10. But this also violates the heap property because 6 is now greater than its right child, which is 3.
Gotcha.
So the solution to that's not that bad. All you do is just look at both sides. You say like, okay, am I greater than the left side? Yes, I am. Am I greater than the right side? Yes, I am. So I'm going to look at both of those and decide which one I'm going to swap with. And I should swap with the lower of the 2, right?
Yep.
Now, what's funny is that now that 10 is here in this spot, there still might be other children of this one, like, right? If you imagine if the heap is bigger than this. So you just have to keep pushing it down until you fully satisfy the heap property.
Nice, so, but that's also a log n pop. So
that is
that's
totally
great.
log n, yeah. It is double the amount of comparisons as the push because you have to look at both the left and right side.
Yeah, but it's 2 log n, still log n.
Yeah, exactly. So that is our priority queue.
That's great.
Yeah.
Wow.
This is actually one of my, I think I mentioned last time, I made this very nerdy comment, which I think I said, like, this is my favorite data structure. Because it's like at the very edge of my ability to keep it in my head, I think. You know, there are some data structures that are like really, really complicated.
Oh yeah, some are bad. No B trees, please.
B trees, yes, B trees, all kinds of trees, right? Red black trees, KVL trees, all these kinds of things that I can't keep in my head. But this thing is like, how do you store a balanced binary tree in a flat array, which is nice.
That's really cool, and I like that it's both space and memory efficient. That's just delightful.
Mm-hmm. Yeah.
Sorry, space and computation efficient.
Yeah.
Space and memory are the same.
Yeah, it's probably not super cache friendly, but that's probably not your big concern when this thing gets really big.
Not for this case, at least. Everything we're doing should be in RAM, so delightful.
Yeah. So now, all that being said, like I don't know, like it's kind of like an exercise to us later on to kind of ram this thing into the Pathfinder. I'm not sure how badly we want to do that right now.
Maybe would it even be that hard? It really is just we just push and shift.
All right, you convinced me. We're gonna do it.
Just do it. Wait, does your priority queue work?
Well, funny you should mention that.
There's a test. Great.
There is a test suite in here.
Yeah, just swap it in then, because we've got it's just an array.
I read another computer sciencey program to test this because I wanted to make sure that like the priority queue like worked for everything, and so I was like, how can I test it? Like, how can I exhaustively test it? And it was basically like, well, I should actually just take a series of numbers and push in every single permutation of them and see if when I pop back out, I get the same thing every single time. So I had to write a permutations function. But amazing. This gives us pretty good confidence here.
Mm-hmm. Yep, I trust it.
Okay, great. All right, so let's do it. We're going for it.
Yeah. So wherever we set up to visit, let's just instantiate.
To visit is here.
There.
And And so what toVisit's going to end up being is a new priority queue, right? So a priority queue is an object that we initialize with a comparison function. It also has a type. And the type will be somewhat interesting to think about, right?
Is it not of type number?
It's of type number, but so this is actually kind of this is actually going to become a very interesting problem now that I think about it. We need to be able to compare toVisit.
The comparator is basically written, right? Because
what comparator were we using before? It's down here, right?
Just use that. In fact, we could store vectopause and then you're probably fine. That's just a string.
Oh, we totally can just do it. Oh, because the nodes are in a different array. That's perfect.
Totally somewhere else, yeah.
Yeah, okay. Because I was worried that like we'd have to store the score. We'd have to store this on the thing that we put in the priority queue directly.
Oh, nah.
But the problem is this changes, right? We reevaluate this value if we find a faster way of getting to the node, right?
Well, so that I guess that is still true. Yep. An item in the queue can be stale.
Well, it's not going to be. Oh, you're right, because it needs to resort, right? If it's stale.
Now, in terms of the priorities of a priority queue, is that we might find a less than ideal solution pathwise. Is that like maybe the consequence?
That is the consequence. So actually, let's just take a look at good old Dijkstra again. I think Dijkstra has something to account for this. Where there's some priority queue pseudocode in here, right?
There we go. Using priority queue.
It has this
decrease.
So that is very interesting. So you're right. It still can be stale when it's in there. So
I'm willing to accept the suboptimal path. It will still find a path.
It will. And I think in our case,
we'll just have like maybe a slightly drunken pilot builder who goes a little out of the way. That's not bad.
Okay. Yeah. Can I think for 1 minute to see if there's an easy way of doing this?
Yeah, totally.
I mean, you'd have to have a way of finding. When you decrease the priority of something, you'd have to find a way to locate the value inside the internal storage. And once you figure that out, you can either percolate it up or down the heap structure based on. You'd have to try it one direction and the other, basically, right? You'd have to try to either push it down or bubble it back up.
One implementation I've seen suggested is to store a map of value to index inside your priority queue, so you can reverse it.
Oh yeah, and so basically that gets.
Then you can like at least you can like basically run the operation from there, right?
So you basically have like a hash table inside of it as well. That like.
Yeah, and then I guess when you decrease or when we update priority, you go to that one and check parent and check children and just and really you're only checking parent, right? Because we're only decreasing. So the only chance you have is that you need to bubble up what's been decreased.
Got it. And so basically anytime you do a swap, you're also updating the hash table on the side as well, right?
Yep.
Okay. That seems reasonable. I think
it's not terrible.
I think I agree with you that maybe we should do it later and we can just let this be drunken for now.
Just put it to do in the priority queue.
Yeah.
Because like the nice thing is it only improves the algorithm, but it keeps running.
Yeah, exactly. I imagine the thing that you're talking about, like have a second data structure is probably the way a lot of data structure we use every day. That's probably how they work.
Yeah.
So
because it's constant space and constant lookup time.
Yeah.
So it's like immaterial, and you get a log-n decrease, which is nice.
Yeah, I mean, if you think about it, like a Ruby hash is an ordered dictionary, and in order to maintain that order, you have to like remember which keys were inserted at which time. And so basically, you probably have not only do you have your hash table, but you have a vector of the keys in order that you can iterate over, right?
Yep.
Similar type of idea. All right, let us proceed in that case. So it's just number, as I think you convinced me. It's just...
Yep.
And the comparator... We need to know about nodes. Is nodes available to us?
Yeah, should be.
I mean, it's basically just this whole thing, right? I could take it.
You could take the entire thing, yeah.
Sorry, my mouse is a little slow through the capture.
No, you're good.
Where's nodes defined? Oh, it's defined up there. Perfect. In the priority queue, we just need to import.
Nice.
Okay. And then while toVisit.length. This is toVisit.pop. And then we say toVisit. We're concatenating them. So it's basically, we're going to push each one of these things, right?
Oh man, this gets so much easier.
I think that's it.
All right, turn on debug draw first. I want to see.
I think our debug draw is broken.
Ah, fuck, you're right. Hey, that still looks right to me.
That looks pretty right. I think this level's not very interesting from this perspective. Let me get one. Damn this inventory. We need a cheat code that disables inventory. Oh, I can't get through.
You can still send the builder out.
Oh, that's true. That's true.
That's too far.
The builder has a range.
He's got a range, yeah.
We keep making the game less fun. Is that really that far? I'm right-clicking.
Seems that way. Wait, stand on the safe side of the wall. There you go. That looks good to me.
That looks pretty good. It looks pretty good. It's funny, this is too far.
That's too far? Well, is the range as the crow flies from the player, or is it the number of steps it'll take? It's the number of steps it'll take, and that's too many steps. Yeah.
Yeah.
15 steps.
15
steps.
steps.
Turn it up. We got more computation.
We do. We have, I mean, this is going to like exponentially increase it, right? But it should definitely be faster now, right?
Yeah. That's so rad.
Okay, this is still too far for him, but he can go now.
Just barely. Yeah,
that's pretty good.
That looks right to me.
They do this little zigzag. It's so funny. On the way back.
Oh, that's funny. Yeah. Is it not taking diagonals? Those are diagonals. That's why it's doing that.
Yeah, it is taking diagonals. It's just that, like, we don't have any heuristic to... I mean, that actually doesn't seem like the shortest path, right? Like, you know what? Like, it basically... we're not adding a penalty for the number of direction changes. Like, I bet if we, like, preferred different direction changes, it would, like, smooth out that diagonal, right? It would basically make the diagonal one continuous thing.
Yeah, and I think there's like a path optimization where we could be doing more lines of sight between path points to see like how far you can step with a vector, like with a continuous vector instead of going tile by tile.
Agreed.
We should be shooting more rays as we walk, essentially. Which whatever.
Yeah,
Someday.
yeah, something like that. The other thing I think of when you say that is that we just partition the space in larger tiles. Like right now, our tiles are like individual tiles of the map. It's too literal, right? Like we could be doing like huge squares, right? We could
Yep.
be subdividing it a little bit more intelligently.
That's interesting. So you could find it out. You could find the best path through that, and then chunk it into like when you get into a square, like do tinier pathfinding inside that. That'd be neat.
Yep, exactly.
Cool.
Yeah. Yeah, I actually think that a lot of video games, the design tools let you do that. That you like lay out like geometry that is continuous. And then I guess the overlaps between that geometry are your edges on the pathfinding graph. And then your units just need to know how to like traverse from like one corner point of your geometry to another corner point, and then it's basically figuring out which pathfinding nodes that the level designer has laid down should your unit take. Now that doesn't quite work if we can create walls dynamically in the game, which is a big selling point of this game that we're making right now, right? So
yep.
I wonder what happens if we crank this up like really big. Is this gonna die? I mean, technically it was fine last time, right? Like
it worked.
Yeah.
I mean, walk all the way over there. It's our algorithm's pretty. Shoot 100 of them. What do you get? And start moving around like that. Those are honestly, that looks a lot better. It's actually working.
Yeah, it's pretty smooth. It's pretty smooth.
Nice.
I like how you can run away from your builders.
I know, it's really funny.
And they're all pathfinding.
Yeah, I think honestly that's a really incredible improvement. Nice work.
I didn't even know what to expect. I sort of violated the cardinal rule of optimization, which is to measure before you cut, and I just cut and cut. And cut.
I know how to measure, which is just stash these changes real quick. It'll be terrible. The game will slow down.
Yeah. Do you want to try it?
Yeah, let's watch it lag. It's always fun.
And we should change the path length back to 100, right?
Yeah, back to 100 and see how bad it goes, because it's going to be very bad.
It's going to be horrible, yeah. I'm going to wait till it compiles before I save.
I just started a new project at work where we're doing a CSS library from scratch, and I was like, I did a prototype in Parcel, and I was like, you know what? Maybe I can see the lag over here. That's not great.
It feels roughly the same. I'll be totally honest with you.
Yeah, when you were moving on the way back, I thought it was fairly
okay.
Evident.
Now it's lagging a little bit, but this is actually more than I did before. All right, let's like.
Mm-hmm.
Okay, so that's about 30 of those guys, and it's like you can feel the lag right now, right?
Yeah, that's terrible. Laggy. Yeah. Okay, stash pop, and let's see if it fixed that.
Yes.
Sweet. All right.
Did this not restart?
Oh no, because you killed the watch process. You gotta reload it.
Oh, okay. Yes. Did I restart from what were we just measuring? Was that before or after? I don't even remember.
Damn it.
I think it might have been before. before the stash.
Now I'm not sure. All right, yeah, it's still kind of laggy, huh?
It's kind of laggy, yeah. But I don't think we ever measured the...
I don't think so either. You didn't refresh it. You're totally right.
Yeah. Look, I can do this all day.
Hell yeah.
That's Captain America. Um, I watched that again a couple weeks ago. Captain America, the First Avenger. It's like
Honestly, a great movie.
it's really good. Yeah.
Yeah. It's got a lot of that Indiana Jones joy to it. Like punching Nazis is always fun.
It's great. Yeah. And then Chris Evans is really good as Captain America.
He's maybe one of the best casting choices in that entire movie series.
Yeah.
Yeah.
Okay, here we go. One
ready. Oh.
Yeah. Oh, I did I right click on a wall? That's what happened.
I thought we fixed that. Boo.
I don't actually remember. No, actually, it looked like it was. Well, we'll see.
Yeah.
I should just be able to like figure it out right now, right?
Yeah.
I mean, this doesn't seem terrible.
No.
This actually feels better than last time, so maybe I made it worse. So.
But this you do it on the hard map. This map has nothing on it. It's only doing 6 comparisons for every object.
Good. Call.
I think the control cases go below. We want to be down here. Yeah, because they have to interact with a lot of shit. It's laggy.
It's laggier.
Yeah.
Maybe not by that much. I think what we can do is just like do a benchmark in code, right? Like I think that's probably the way to do it.
Fine.
Yeah.
Yeah. That's great though.
But
this is awesome.
I'm fine just saying that the more complicated thing is better, just because that makes me feel better inside.
Oh, I'm a big fan. Oh, you got your 100 change in there. 1 hundo.
Okay, so we have added some optimization that just makes us feel better about the data structures here, and it was surprisingly easy to drop in, except that when do we need to reevaluate the lengths?
When the score changes. Oh, do we pass? We don't pass to visited. We do in get neighbors nodes. Further down, yeah, we update our node score here.
Okay.
I say decrease priority. Yeah.
Okay. Very good. We've got
sick.
All right. So, what do you want to work on today?
That's a great question. What
else is there in this game? Is this game done?
Feels that way.
No, I'm kidding.
You got everything. You got baddies, you got inventory, you got health.
Yeah, we've got all those things.
You can lose, you can win victoriously.
Yeah.
Let's see.
The turrets can shoot. We've got team affiliation, we've got pickups.
Got friendly fire, which is great.
We do have friendly fire, yeah. We have a host of bugs, but it's not super compelling right now, or at least we're weaned on Silicon Valley. We want to ship as many features while fixing as few bugs as possible.
I've seen some buggy ass games too. We got less bugs than a lot of games I've paid money for.
It's true.
Let's see. I can think of a couple of things. One, our collision detection is still maybe kind of jank.
Yep, it is.
The way I kind of wouldn't mind figuring out a better, the way our bullets and our player rotate, like we don't actually have like good dodge ability. Like the player is always facing upwards even when you rotate sideways, according to the hitbox. You've got like a funny hitbox. We're not doing rotated box collisions.
Like this.
Yeah.
Yeah.
And also you can't drive through tiny spaces with that, but also like a bullet hits you in a funny spot.
Oh yeah, that's definitely true. Yeah. And it's funny because like I think we had complained that like our like our boxes relative to the registration points here. You notice how they're like slightly weirdly offset because they're like
Right, and the bullet hurt box isn't quite on the bullet. I wouldn't mind trying to figure out sort of what is. So we've got a couple things that are mathily wrong.
Yeah, I learned a cool trick that a lot of the like bullet hell games do with their bullets.
Yeah.
All of their harm boxes.
1 pixel.
1 pixel. They're not even harm boxes. They're not even boxes. And as you can imagine, if you have a shit ton of them, which is what those games are about, it's like really hard to process. I mean, how many comparisons do you do for a single pixel? You compare it to a hitbox, and that hitbox is, you basically do 4 comparisons, right? Am I less or greater or less than the X extrema and greater or less than the Y extrema?
Mm-hmm.
But that becomes suddenly a lot more complicated when we do AABB collision, right? So like all of our bullets could theoretically just be a pixel, right? Just the registration point.
I kind of like it.
And it would probably feel fine, right?
Yeah, especially because I like that it adds to the feel of like near misses. It feels like the game forgives you, but you can throw more at the player, essentially.
Yeah. Even the big things in bullet hell, even like the big bullets, are still just a pixel.
That's amazing.
There's probably a limit past which that starts to feel really funny, but the big bullets are there just to make you nervous. Just keep that in mind. Yeah. But I think even if we make the bullets a single pixel, it's not going to change the fact that like our rectangle here is not rotating, right?
It's pretty weird. It'd be really nice for that to feel right.
And it certainly making the bullets
hasn't felt wrong so far, though, right? It's weird.
It's been like okay, right?
Yeah.
It's been reasonably okay. Honestly, I think the bullets are small enough that like I kind of can't tell.
Yeah, well, then maybe a counterpoint or another path.
We start over from the beginning. Oh, that's brutal. This game is merciless.
Oh yeah, you could remember which level you're on. That might be nice.
Yeah.
We could also think about the like terrain layers. Like, do rivers and mountains slow you down? Are there trees and more inventory to pick up? There's sort of like a player interact with background layer system going on.
We could do trees is interesting, right? Trees are entities; they're not walls.
Mm-hmm. Yeah, you can destroy them. They do check for collision. The builder can pick them up. Do they block view? They're not walls, but they block line of sight.
That
sounds fun.
It's very rich.
Yeah,
and technically you're invisible inside trees, as well.
Yep.
All right, let's do trees.
I like it. So I have a little blind to sneak up on the turrets with.
Right. That's not what I wanted. Okay, so let's talk about trees.
Mm-hmm. So definitely an entity.
Yes, and then what systems does this affect? Trees will affect
shooter.
Yeah, and I think we're almost thinking of like you know how wall is a flag.
Mm-hmm.
It's almost as if we need a separate thing where wall is the thing that obstructs your motion, and then there's another concept of something that obstructs your line of sight.
Mm.
And that would be inclusive of a lot of things, right? It would be inclusive of people on your team, like other entities that can shoot you, other players.
Yep.
Right?
Right, because you might be able to, you wouldn't want to shoot through your players, but you might be able to move through friendlies. That's really cool.
Yeah.
Mm-hmm.
So trees are definitely entities, but the components that they're made of and the systems that they influence, open question, right?
Mm-hmm.
Okay.
Yeah, and they're not pickups, but they have a drop? Maybe we'll get to wood later. Wood might be a lot.
Sorry, I still got my work reflexes with the semicolons.
Does our formatter not catch them? Fat arrow. Yeah.
I got a new keyboard, by the way. A new one, a new one, even beyond the one that was new from before. But it's very similar.
I hear some good clicky. Clicky is nice.
It is still a Cherry MX Brown.
Okay.
For all you mechanical keyboard switch nerds out there.
It's everyone.
Cherry MX Nation. No, but so my keyboard before was the Kinesis Freestyle Pro, which is the mechanical version of that split keyboard that has a wire running between the left half and the right half.
Oh,
and then I upgraded to the Kinesis Freestyle Edge, which is the gaming version of that.
Oh my gosh.
Yeah, so I can have I right now have backlit keys. I'm staring at them now, and they're actually lighting my face right now. This the glow that you're seeing right now is from my.
I got to zoom in on that, but oh yeah, you're positively glowing.
I'm actually joking about the, but yeah, that's the keyword right there.
Nice.
Oh, did I just screw my? Yeah. So the reason why I switched, actually, the other keyboard was fine. It was great. It actually convinced me that I was like, oh, I could upgrade to the similar model and be fine. But I ordered the palm rest kit. They definitely have a lot of upsell at this brand. The palm rest kit that I got has these neoprene rubber wrist pads, and I think my skin was reacting to them. It was weird.
Oh.
It was I was did a day of programming, and I was like, I'm kind of rashy right now. Is that from the thing, or am I just not used to having the contact there, or what?
Oh, you don't want that. That's no good.
I think also they made my hands smell like rubber, as if I was gripping a pencil eraser for an hour, So I was like, you know what? I'm spending hundreds of dollars on keyboards. I'm going to get exactly what I want, So I returned the first keyboard and then got the second one. And the second one came immediately. I was really not expecting it to arrive in time. And I was just happily back in the realm of my Apple Magic Keyboard that I stole from my office.
Which is fine.
No, it's great. I love that keyboard. Yeah. But this new one came today. In fact, right before the stream started.
Nice.
So not only did I spend 15 minutes trying to set that up, but then I tried to use a different keyboard for the PC. It's just a long story of why it took us so long to start the stream today.
I gotta say, I'm in love with this keyboard with 3 Bluetooth memories, because being able to single key press to switch from laptop to Windows PC is a real lifesaver.
So now I'm going to return this keyboard and get yours.
Mine's not. It's not ergonomic. It's just a hacker keyboard. You don't want it.
Wait, I thought you had a keyboard that had backlight on it and that you were upset.
Yeah.
Oh wait, is that different than before?
No, same one. I love it.
Okay.
Here's the backlights going.
What? Oh my god, that's crazy.
It's wonderful.
And it's tiny. Is that less than? It's not even a 10 key list, right?
No, it's 10 key list with a full size Aero pad. Oh. It's honestly the perfect size keyboard.
Yeah, this one thing that I liked when I went back, that might sort of the intermission period where I was between mechanical keyboards and was using my Magic Keyboard. So all of 2 days, right?
Yeah.
I realized that the Magic Keyboard is the perfect size for a desktop.
It's a great size.
It's really, really a perfect size. And now I've got this gargantuan monster with now kind of faux leather pleather, if you will, wrist pads on it, which are less smelly and hopefully less skin irritating than the other ones. Time will tell, because I've literally been using this for the last 20 minutes only. But we'll see.
Dude, whatever. The Kinesis stuff is so good, though. You're not going to have carpal tunnel syndrome. It's worth it.
It's true. It's true.
Don't fall into my trap.
Do you have carpal tunnel?
No, but I will.
Okay.
I'm not doing all my ergonomics now. It'll catch up to me.
Well, I mean, the whole reason why I fell down this hole of like buying new gear and getting a desk and everything was that I was starting to not carpal tunnel per se, but like certainly some sort of RSI from like using my MacBook laptop on my kitchen table for 8 hours a day. That was starting to kill me.
No way.
Yeah. Well, I did it for 3 months or 4 months or 5 months or however long we've been in lockdown. So
that's long enough.
yes, let's make a tree.
Yeah.
All right.
But not a priority heap tree.
No, we've done enough of that for today. E dot renderable equals new path renderable.
Green circle?
Come again?
Green circle?
That would be great, actually. Yeah. How do I do a path renderable? It's a path, right? It's not.
Oh.
Is there a way I can do renderables that aren't paths? We don't have such a thing yet, do we?
I thought we have an entire circle component in the renderables, don't we?
We do, but we don't have a renderable component that is that. And there's no reason why.
Wait a minute. How do our turrets render circles? We already have circles in here.
Oh, we do have circles. You're right.
Yeah. Yeah, look at that turret renderer. I think we did it.
That is
not the turret system.
Sorry. We have like a full React problem right now where it's just like all this stuff.
React.
That is a straight up separate class, which whatever. I'm stealing it.
Huh?
It's just not a reusable class, which is fine. And then what we're doing here is the renderable. None of this matters, right? None of this freaking matters.
None of that matters.
Do we need to set fill style? Is that required on the?
I think it's required.
Come on. No definition. Oh, it's because I haven't imported yet. Boy.
TypeScript.
You're punishing. It is required.
But the style is just green or unimplemented, right? I think we have one of those, or it just doesn't accept it.
Trees are green.
Trees are green. Agree? I would agree.
And then
yep.
I think that's pretty much it, right?
Yeah, and then just get everything imported.
Boom.
Love it.
And this is new. Tree renderable. Don't you wish you could make like an inline class? Wouldn't that be cool? Just like define the class right here.
That'd be so nice.
It'd be neat.
You can't do that, can you? Not with this language.
There's a language out there, or a language feature out there that would let you do that. I haven't decided in my head what that is yet, but it would be cool. Like anonymous classes.
Wasn't Java's all over that? You can make all sorts of anonymous classes in Java, right?
You're probably right. Yeah, because like Java, the way you used to be able to do closures in Java without like you had to like make a class. Do you remember that? Like you had to like make an object.
Yeah. Wait. I think you could do this in JavaScript.
It's just like new class, open curly brace.
Yeah.
What? No.
No. That's too bad. It should be.
Yeah, because I think in Java you would do something like that, right? You do like new class blah, and then would just like create it right there, right?
Mm-hmm. Yep.
Well, I think TypeScript is a nice enough language. I'm not gonna. I'm gonna count my blessings here. All right. So how do we get the level editors to make these things show up?
Oh no, we have to do that, right? Every time we add an entity.
Oh yeah, we gotta. Boy, is this a level editor fixing day? Is this what's gonna end up happening?
It could be.
It feels like this is painful enough that we probably need to do it. What were the controls again? Was it E or R to do entities?
I always forget. I think it's one of those.
It's
yeah.
F.
F.
What an amazing interface I created here. They get to do some grass, some friendly little grass, brilliant, nice little grass.
Mm-hmm.
And let me just make sure that this still works. Okay, cool. I reloaded and it looks good. All right, so we need to be able to like pop an entity in there. And let's look at the map editor. That is way down here in tools, in tool land.
Haven't been there in a hot minute.
No, it's been a while. I'm gonna have to actually remember exactly how this thing works. And then when we have entities, there's some list of types here.
Entity types, yeah.
So
yeah,
I mean,
yeah.
I guess we can start by adding this, right?
Uh-huh.
I like how we have an entity called Nada.
I regret that already.
Really? I kind of like it.
It'll certainly never be confusing.
And then we have to repeat this here
Mm-hmm.
for reasons I'm not sure of, because theoretically this thing is already in oh, you know what it is? It's because of iteration order.
Mm-hmm.
Sort of. Because whatever the hell this compiles to, I think it actually compiles to an object that contains a lot of stuff.
Yeah, it's not just an array.
I think it's an object that has reverse mappings between the name and the underlying value. Let's check this out here.
Oh shit.
Oh shit!
I never even thought to do this.
Yeah. Well, actually, this isn't so bad.
Object.values type. Can you hear the drag race happening outside my house? It's been going for an hour.
You know, your street is not really suitable for a drag race. I'm gonna put that
it's
one
really
out there.
not.
Yeah.
I'm a little surprised.
Your street is like a bucolic neighborhood to raise one's kids.
Mm-hmm.
Except for the scourge of Berkeley drag racers.
Tonight it's a drag race.
It sounds pretty high pitched though. Is that a motorcycle that we're hearing?
Oh, maybe, but they've been revving it for a while, and I'm really not sure why.
Okay.
Could be motorcycle.
Yeah. So I have encountered numerous issues with trying to go from a raw, plain old data JavaScript type, like an integer or a string,
mm-hmm.
into its enum representation, if that makes sense. That ends up being a huge pain in the ass. I made this is the best I could come up with. This two-string enum thing, where it takes the enum object, in this case, type,
mm-hmm.
and that actually at runtime is this monstrosity, right?
Mm-hmm.
And it takes a raw string value and then attempts to basically find it, that raw string value, in the list.
Holy shit.
And then returns all this friggin' nonsense.
Dude.
And that's how you get one of these suckers back. This thing. Or this thing. Which is fine. We can do it.
I like that we just have it written twice at this point.
Yeah, okay. And
it's worse.
Yeah, I mean, I think we're actually touching on. Do I say this too much? Everything that we do has this like whole world of complexity sitting underneath it.
Mm-hmm.
And
I don't think you say that too much. It's usually true.
I feel like I say it about everything that goes into this game.
Mm-hmm.
where my head is going is that where are the entities defined? Are they defined in the game, or are they defined in the map editor? And if they're in the game,
That's the real question. Yeah.
what extra data about an entity does the map editor need, right? Or maybe there's like some representation of map editor entities, or sorry, entities in general that have interfaces for both the map editor and the game. That's probably the solution that we'll end up taking up.
Mm-hmm. It would be nice to move away from the thing you're about to do is get into the strange map editor mapping with like the separate models, and that's what I really want to get rid of.
Okay. And what we want to be able to do is like render the entity in its full glory, like as the full model.
Yeah, I want to see like the turret on the tank.
Okay. So let's take a look at that real quick. Is it the player renderable? Mm-hmm. And this returns both of these things.
Mm-hmm. Yeah, and we've got a renderer that takes these and knows what to do with them.
Yeah. So I think before we talked about having like a model abstraction, right? Because in the map editor, you're not going to have transforms, right?
That's the problem. Yeah.
Everything else is constant. The body path, the fill style, all these other things are just like, they're just sitting right here, right? They're fixed. They're not changing. But you're not going to have a transform. And so is there a notion of a model where, and is a model just another class? Like, is each one of these just like a separate class? I kind of hate that, but
it's not. It could be more elegant. Well,
I think the way that
could the model be basically this without the transform applied and like a optional key of some sort? So if we wanted to apply a transform to every individual model path with like key turret, we could apply the turret transform here. So the model is a series of paths with the identity transform.
That is very interesting. Yeah.
Yeah, and then the map editor can apply its own transform, which is just translate everything to map coordinate space. So basically, just delete transform from this, and we've got our model structure.
Yeah. Would the model, but the model structure also needs to support things like circles and potentially even lines and things, right?
But this does, because these are your primitives, right?
Yeah, the primitives don't all have MW transform, but they'll have some notion of like what to transform. So we could have a transform primitive function that knows what to do with each primitive type, right? Yeah. Okay, this is good. I love where this is going.
I feel like we can at least wrap that up nicer. But yeah, this data is what we want.
Okay, so I'm throwing this in at the very top.
Whew.
It is a class.
Boom. Okay.
And is it just an array of primitives?
Let's start there.
Okay. Maybe a key value thing of primitives, like a mapping of primitives, and we just assume the iteration order is set, because there needs to be like a layering kind of like we need a draw order of them, right?
Mm-hmm. I mean, they could get like Z indexes of some sort too, because as it gets more complex, if we have like a 4-part model that renders like a center and a left, right, and like a cockpit or something,
Oh, interesting. Yeah.
We might have 3 things on the same layer, but like a base layer below that.
So maybe what we're talking about here is a private primitive. Is that what it is? And it's an array of this, and the first array is
Oh yeah, cute.
is just the like which layer is it on?
That's great. Yeah.
And then I need to give this thing a name. Although we did want to be able to like label things directly, right? We wanted to be able to index them.
True.
So is it instead a primitives is a maybe a mapping whose key is a string to a tuple of a primitive and a z value?
Mm.
Is that too complicated?
No, I don't think so. That's nice. Still need a. Oh, we've got the key. Yeah, that's. I'm into that.
Come on, man. Give me the tildes. And do we just take that as the... do we just take this as... don't you love these constructors?
Oh, so good. I wish there was like an implicit constructor in TypeScript, like there is in a couple other languages, where it's just like, you always get that one. You get the one that's just set all your properties.
Where you do this. This is how you do it in Hack. It's really ugly.
I don't like that. Huh.
Right. But that was actually CoffeeScript, right? CoffeeScript also did that. CoffeeScript let you do this. Like it used like this Ruby syntax. That was
that's assignment in the constructor signature?
It's basically actually it doesn't have line number 4 either. It's basically you have
there you go. Okay. Neat.
Yeah. But you know what? This is fine.
This is fine.
And then we have a render function.
Uh-huh.
And it takes a transform, right?
Does it take a transform or many transforms?
That is a great question. It takes...
I think it takes a transform function that gets handed every primitive and chooses what to do with it. Ugh.
Do we end up reinventing the OpenGL? Well, I think what we want to be able to do is there's like a per primitive transform, and then there's like we want to compose that with a transform that the entire model, like basically we want a world transform and an array of or an object of model transforms, which could be. Okay, that's it. That's it. So basically what we're saying is we have like the world transform, which is a map 2D. And then we have model transforms, which is this structure.
Clever. Just yep. So that you can apply them as you want. I love it.
I really like the way today has gone. Like at first we were just like, what are we going to do today? But this is actually going to be great. I'm really excited for this.
And strangely, everything was trees all the way down.
Yes. Okay, and then I think maybe what we want now is... I'm gonna ignore the depth for now. Let's add this as a feature later. I think it's gonna be kind of a pain in the ass.
Okay.
But let's let's just assume that like we've just defined things in order and that JavaScript iteration order is being respected.
Great.
Which I think it will.
It's easy to add if we want it. It's no big deal.
Yeah. Exactly. And so the way that this is going to work is we will basically say for const k in this dot primitives, but transform equal mat2d dot create. Does that exist?
What? Yeah, there you
go. And then if model transforms k, mat2d dot copy
This copy
needs to have an argument. I'm sorry. All right, and then we multiply that by
transform, row transform. Yeah.
Is this the right order?
I think so. It's the order that we do it in right now, isn't it? We do what little model transforms we have in the renderables.
So this would imply that the thing that's like this is A times B, and that would be, and then it would be B times the vector that's getting transformed. I'm not actually sure which order they compose. It's always confusing, and we'll just do it right now and see what happens.
Cool.
Okay, and then what we're going to do now is we switch on this dot primitives k dot type.
Dot primitive, I think.
Dot primitive, yes.
It's weird. I guess. Isn't that what's there?
Oh no, wait, it's not. It's a renderable is what we want, not a primitive. Sorry.
There are no primitives. Wait, what did it import?
It imported the enum, which are the different types.
Yeah. Okay.
And then so this is actually renderables, right?
Yep.
And this needs to be okay. Now we switch to the primitive and we do case primitive dot. What's the ordering of these things? Path, rect, circle, line, text.
Man, woman, camera, TV, baby.
What is that from again?
It's whatever list of 5 words Donald Trump couldn't remember.
Oh, are those the things that he wasn't supposed to say, or like what was the?
Did you miss this? It was they gave him a cognitive test, and it was like remember 5 words, and he was very proud to have remembered 5 words. And he said them like 10 times in one interview, and it was very strange. It was a funny thing to brag about.
Yeah, I was reading today. Was it that he was? He was like? I don't remember what it was. He said something extraordinary that just made him seem insane more than evil or anything like that.
how, like, what new horror could he release on the world? Shit.
What fresh hell, right?
Gosh.
Sorry, I'm just respecting the order in which these were defined.
I mean, as the cognitive tests prove, it's hard to remember 5 words in order.
It really is. Okay, now path, what do we do? We just transform every single item in the path, right? We want to render it. Am I redoing a rendering thing? Am I just returning one of these things?
Doesn't the renderer do this? We just want to set the right property. We want to set. Oh, can you go to the renderables interface? Because you're saying everything doesn't have a model world transform. Is that correct?
Well, the model. Where is the renderer? You're right. The renderer already does this.
Yeah. Yeah. Great, because it applies the camera transform, which is great.
Well, no, the renderer doesn't do this. It applies the camera transform, but it assumes that the model world transform is good to go.
But it is, because we're setting it. The model world transform is the transform we're setting. Like, isn't that just the position? Because that is from.
It is, but I think what we're actually doing is. We're going to pass renderables here, but the renderables need to have their world position set already by the time they get to this point, right?
Right.
So what the model is a renderable, like these renderables are in as if the world position was the origin.
Correct.
And what we need to do for this render is actually get renderables.
Yep.
With some transforms, right? And this is a renderable. But we're not just blindly returning what we have internally, right? We need to actually return them with the transforms applied, right? Why is this complaining?
What the hell?
It's because I'm not returning it yet.
Yeah.
Okay. So really, this is actually a map, is it not? This is like a map over our renderables.
Yeah.
But we can't do a map because it's keyed by a string, so let's just say const result equals, and it's going to be a array renderable. That. And then what we're going to do is, how do you do a shallow copy in JavaScript?
Fuck. That's a good question.
Is it just object dot
assign?
Assign. Oh, you know what I can do? I can just do the friggin'.
You can splat it, yeah. Yep.
All right. And so why don't we do this? And then what we're going to do is we're going to just basically for the path, we just say like, well, we have to.
Wait, is this? I feel like you're very close to redoing the entire renderer.
We just need to update the transform behavior, right?
Yeah.
And then for a rectangle, is it the case that maybe we should have a model world transform? Like, should we redefine some of this stuff so that they all have model world transform? Or...
Well, maybe the simpler thing right now is to it's only for the path, huh?
Yeah, we could just throw exceptions if we do anything else besides circles or paths, because we don't really use anything else for now, right?
The circle also just has a pause, right? Yeah. So maybe it's really just that we need to, like, your switch statement is if it's a path, apply the model transform. Otherwise, shit, we don't actually even apply these transforms to anything but paths. Maybe the switch needs to happen earlier.
Well, I think an equivalent of the Marble transform can be applied to each one of these things. We just don't express it like that, right?
Okay.
So text is actually going to be kind of ridiculous. Like, I don't know if we should. You could make it, but like we wouldn't be able to like scale the like if your Marble transform does any kind of scaling or skewing, it wouldn't apply to the text at all.
I'm okay skipping the text because none of our objects will render that.
I am too. But like lines would be easy. What you would do is you'd apply the model world transform for both from and to.
Okay.
Circles and rectangles are complicated because you'd need to calculate what the new radius is based on the transform. Now, we're not doing any like reshaping or resizing of models right now, but the model world transform technically is a matrix, and if we're to respect everything the matrix can do, probably what we'd do is we'd add the radius to the vector.
Gotcha.
Figure out that vector, multiply the endpoint of that vector times the transform, and then calculate the new radius based on that, right? And then we basically recalculate that. And something similar for the rectangle as well, but instead you'd use the corners. But you know what? I'm cool just doing paths for now. Well, we need to do circles, right? If we don't do circles, then we can't draw the turret the way we want.
Yeah, path and circles, and I think that actually covers all of our, everything with walls. We can make a wall with a path.
Is a wall a rectangle? I think the wall is a path, right?
Oh, even better. I thought it was a rectangle. That's great.
Come on. All right. You made it, TypeScript. You made it all this way. So that's that. This is going to be a little bit interesting. For now, I'm not going to worry about the scaling.
Mm-hmm.
And what is this? So here's an interesting thing. When we define the model, it kind of shouldn't have this, right? It kind of shouldn't have...
We need like a new interface. Yeah. Should we have a path, a model path and a model circle for just this class? Because they are a subset of this.
I agree with you.
And that's fine, because like whatever, we don't need interfaces anymore. It'll just work.
So it's basically like, should I just copy this kind of style thing?
Yeah, just copy it and let's just keep it to 2.
Yeah. I'm totally with you. This is great. We're not going to finish this tonight, but I think that this is a really...
No, but it's good.
Yeah. And then, do we want to reuse the word model primitive here, or should we rename it to model primitive or model?
We should let's namespace it, because at least we can refactor it later. I feel like everything will become this, but this is the only way to insert it right now.
Model primitive and model
path, yeah. Mm-hmm. Yep, and then they lose their transforms and pauses.
Yep. This is great.
Cool.
And then, let's see. We only have circles and paths for now.
Uh-huh.
And then we have this notion of a model renderable is equal to either model path.
Model path or model circle, yeah.
I love this pattern.
Cool.
Oh.
Huh? Great.
Then I gotta. It's kind of funny how right-clicking doesn't bring up anything for that.
Huh.
And this is these are renderables.
Those are renderables, but the private variable is a model.
renderable. Yes.
Yep.
All right. Very good, sir. And then this needs to get imported. Or no, we're just still not returning anything.
Yeah. But that's okay actually, because we can in primitive path we don't even need to do a copy anymore. We can use this. That's great because we're going to copy it into a new object that is the renderable.
Yeah. So I think what we can do is we'll basically just say like this dot, or rather result. Is that what we called it? Result dot push of something like this, right?
Yep.
Primitive, and then we'd have primitive here.
Yeah, as primitive.path. So we override that key. We can override the key that way. That'll work. Yeah. Yeah, so primitive is primitive.path.
Renderables is what again? It's one of these things, right?
It's one of those, yeah.
And so this is primitive is primitive, capital P primitive, right?
Yep.
Model will transform just that, right? Just full stop.
Is that
we didn't
it's
call
called
it a
transform.
variable. Yeah. Let me actually be very explicit about what it is. And I missed one.
Yeah.
This is cool. I'm surprised this is not reformatting. Oh, it's because I don't. There we go.
Boom. I'm surprised it doesn't like the TypeScript.
It doesn't like it. Argument of type blah, blah, blah. It's not assignable to type.
Sure, looks like a renderable. Wait, Phil.
Oh, radius. Why does it have a radius in there?
I don't know. Oh, you know what? Maybe finish the circle one and just put a dummy pause on there and see if that fixes it. You might need to cast this .renderables as model path.
And then this is pause?
It's just like vec2 something, yeah.
It's funny. It was fine with this one. Oh, this is... it's not fine with it. Circle.
Not yet. It's because renderables could have a... Oh, do case model primitive
renderable. Oh, okay. Well, so first of all, let's...
That's gone, yeah. This .renderable is k primitive. And switch on...
These are model primitives. Yeah. Oh.
Huh. I'm surprised that's not happy.
I am a little bit surprised myself. You would think that it would know what this expands to.
Yeah, I guess we've done a switch on... I can see it as a funny switch, maybe.
So basically, I think what we're saying is... as model path. And then...
Splat P.
It's P instead. Sorry, my mouse dexterity is a little bit weird. There we go. Okay.
Hey.
I'll take this. This is
could be worse.
Not the end of the world. Yeah. That's just the type checker being maybe not quite smart enough.
Yeah, it could infer it. I'm not sure why it's.
Is it complaining that I have? Do I need to maybe wrap this in a block?
Huh?
Because I have const.
Oh, yikes.
And const is block scope.
Fair.
And still.
Hey, it's not a pause. Yeah.
Oh, it's vec2. Wait, what the
Right,
hell did we do here?
Circles just they get the center point from the transform, so we need to somehow pull that out. Because
we need to get the translation.
Scaling.
We need to get the translation, right?
Yeah.
How do we get
that? Translate?
Translate changes it. We could multiply. We could multiply 0, 0 by the model world transform and get the position.
Aye. Is there a vec2 method for this?
There very well may be. I guess it's kind of a toss-up where you would stuff this, right? Angle, ceiling. Where does it take a mat2D?
There's a transform mat2.
Yeah, what I was saying is like you were saying like, is there a function that pulls it out? But we can just do transform mat2.
Yeah, that'll just do it, right?
Identity. Yeah, okay. So let's say the pause is vec2.create, and then we do vec2.transform mat2D of pause model world transform.
It's just pause. All right.
It works. And there's no default here. We've actually covered all the cases.
Yep.
We
got to return result.
And then we got to return. Yes. Good call. And this is in a for loop whose ending is here. Return result.
Were you about to say I don't hate it or I don't love it?
I don't hate it. Question mark?
Yeah.
What did I do here?
I think.
Why is it complaining?
Where are you?
Oh, this is the map editor.
Oh, we didn't even finish this. Yeah.
Yeah, there was a bunch of stuff. We got distracted, right?
Yep.
Okay. This will work though. I don't really hate this.
Nah, it's not bad.
Yeah. It's not bad. We will need to do something about the radius. I don't know what model transforms will scale it. I also don't know what world transforms will also scale it. Probably none. The view transform may scale it, right? But that's fine, I think. Did we already do this in the render? Does the view transform deal with circles? Yeah, I already did this, I think.
Takes the position, applies the camera transform. Oh, there's your zoom. Yeah. Huh.
Oh, yeah. I created the... Yeah. So I actually did exactly what I said before here, where we kind of created a line to the edge, translated that point by the transform, and then okay. At any rate, We'd have to repeat that for the model world transform as well. It almost feels as if the circle is maybe badly factored. The circle should maybe just be like the radius should just be a vector or something like that. As weird as that feels. Well, it doesn't make a difference. Like the radius is a vector. It's just has an x value of 0 that we assume. So maybe it's fine. It's probably fine.
Okay, so given that we're like running out of time, what can we do with our model class right now? Or should we say nothing?
Kind of nothing. I was about to say the same. I know what you're getting at. So what I can do is commit the current work to a work in progress branch.
Let's do that. Yeah.
And then I think we might be able to tinker with this over the next few days and see what we can come up with.
Sounds good.
Or pick it up Sunday if necessary. But I love the way this is going, because what's going to happen is we're going to have this thing. We're going to have this big bank of models, and then each entity is just going to pick up its own thing. And
and then the map editor gets the real entities, and we drop the entire like model path thing that gets passed in. We already have fake models that we get to get rid of.
Yeah. So I actually don't know if. So let's talk this out actually, because I think this is actually good to kind of like cover here. Types. I still think that something like this is going to need to exist. This sort of manifest that maps types to the game constructor, and then to also the model will just point at the new model object that we create here, right?
Oh, I see. Yeah, it'll instantiate. Right. So model will no longer be a parameter back into the make player function, though, which it is right now, which is like the weird thing.
It doesn't have to be, because the make player function could just know where that model is and just point it out. It will mean that we're double defining it. We'll define it here for the game, and we're going to define it for the make player function. I think that's why I pulled model over here and had to pass it into make player. But I don't, at 6 and 1/2 dozen of the other.
That makes sense. Yeah. I guess the alternative is now we could pass the model function into make player, because what we'll be doing in make player is applying our own transforms to it as part of get renderables or something. So we could do that on our own.
You could even pass this whole thing into make player. There's a bunch of like global config that is like the common configuration for make player is this whole big blob, and you pass it in. Or you can make the make player function just know what those things are. If we had more things that we needed to share between the map editor and the game, the more it makes sense to like put all the shared stuff in here and pass it into the make player function. Does that make sense?
Yes. Yeah, exactly. But that's cool. This is good. Because we're no longer. Yeah. Now the models are like a code object instead of this just chunk of data. We can do a lot more. So I feel like we'll just keep this pattern going forward.
Yeah, totally.
Great.
Cool, man. Well, thanks for being patient with me on the streaming technology and watching me slog through, typing through the game capture latency. I know that's probably a little bit annoying.
Now you know my pain for the streaming across 2 machines. It's worth it.
I do know
better.
Your pain. Yeah, it does tempt working directly on Windows, doesn't it?
Yeah, but our stream looks good. Like
it does look good.
Yeah. 1080p. I can read it on the screen. It's really great.
Yeah,
it's worth it.
Nice. Excellent. Okay, well, I guess until Sunday, everybody.
Adios.
Oh, I have to use the other mouse to quit the stream.
You gotta use the other computer. I love when you drag the Mac mouse to the edge. Yeah.
Yeah. You can see me struggling. It's like no matter how hard he tries, he's not going to make it. I'm not going to say anything. All right, here we go for real. Stopping the stream.